Bring it back.
Friction is that feeling you get when your girlfriend tells you to wash the dishes, but you don't want to. But in physics, friction is a force that opposes the motion of an object. So I guess they're the same. Without friction, a lot of the things that we take for granted, like picking up a bottle, walking, or even driving, would be difficult to do. Static friction in particular, though, is a type of friction that prevents an object from initially moving, as opposed to kinetic friction, which is experienced when things are already in motion. Now, you already know a few things about friction. For example, you know that rougher materials, like sandpaper, it's harder to slide your finger across it. Oh, I'm gonna do that again. As opposed to things that are wetter or a lot more smoother, which you can sort of just slide your finger across. Rougher materials have more areas where things can catch on each other when they start to slide against each other. That's why it's easier to slide on some materials than in others. But no matter how smooth an object appears to be, there's always some roughness. There are little areas of contacts where the atoms in the object are going to interact with the atoms in the surface. And those interactions create that resistance that you feel. Friction. Here's a little fun history nugget. Leonardo da Vinci was one of the first people to systematically study friction, 200 years before Newton even defined what a force was. Da Vinci, who is best known for his 2006 box office hit, The Da Vinci Code, and the guy who painted the Mona Lisa, noticed two very peculiar things about friction. One, that friction is independent of surface area, and two, that if you double the load, the friction also is doubled. Now, it may seem strange that the friction is independent of surface area. You would think that increasing the area would also create a larger source of frictional force, but that's not the case, so deal with it. But here's a little secret. It's just an assumption. For example, if the surface area gets too small, then it will just start digging into the material and the standard model of friction just breaks down. Static friction is given as an inequality. The static frictional force is less than or equal to the coefficient of friction times the normal force. One easy way to remember it is friction is fun. Mu is the coefficient of static friction. It's a measure of roughness between two objects and it depends on the material. Those values are calculated for different materials. I guess that's why in movies you see the guy climbing the side of a building with rubber suction cups, and why my synovial joints are so easy to move. N is the normal force, and that's what counteracts the force of gravity. That comes from Newton's third law. One important thing is that the static friction is proportional to the normal force, meaning that if you increase the weight of something, then the friction also increases. So the heavier the object, the greater the normal force, the greater the frictional force. That's because heavier objects are going to increase the number of contacts between both surfaces. If you start to push an object into motion lightly, it first is going to resist that motion because the force of static friction is opposing that applied force. The more you push or pull, the more that static force you'll feel until you apply enough of a force to overcome that static frictional force. When you initially start moving something, like if you're going to push your couch, you'll always notice that it's always really hard to initially get the couch to move. And that's because as soon as you start to apply a force, the force of static friction is applying with an equal but opposite force. It's not until the couch starts to move that you start to feel that the couch is a lot easier to move. And that's because you overcame that initial static frictional force. Once the object starts moving, kinetic friction takes over. Kinetic friction is always less than static friction. It's why it's always harder to get an object to move than to keep it moving, like that couch. We'll talk about kinetic friction next week. To show you the interplay between static and kinetic friction, I'm going to attempt to move 2 tons of material to the lab. Watch the strongest man push 2 tons of metal. Well, that's it.